Hello everyone, welcome to Inside Science Center. I am Pushkar Ire and let us study vector algebra, part 3. In previous two parts, we had studied about these 5 topics: introduction, understanding basic direction, basic concepts, types of vectors. In part 2, we had studied about vector addition and subtraction. Let us study about the next few topics in this part. Let's move on to the sections formula. So what is sections formula? Sections formula's problem is to find a position vector of a point which is dividing a line segment in a specified ratio. Okay, so I'll draw it. Let's say this is our origin. We have a point A over here. Let's say we have another point B over here. And then we have got this vector which is AB vector. Okay. So this AB vector, let's say, has a point between them, which is, let's say, this point. Let's call this point P point. So what sections formula aims at is to find this position vector OP. So we have to find this position vector OP such that AP is to PB is a specified ratio. Let's say that ratio is M is to N. AP is M and PB is N. So we have to find a position vector such that AP. Okay, AP and PB, these two are line vectors which are collinear, isn't it? They lie on the same line. So they have the same direction. So I can simply write down that AP upon PB is equal to M upon N. Okay. I don't think we have any problem till now. Or I can simply cross multiply this equation and I'll get N times AP is equal to M times PB vector. Correct? We have to find the position vector. So we have to find what OP is. So how do we find what OP is? Well, it's easy if we substitute the vector law of subtraction. What is the vector law of subtraction? Well, vector law of subtraction simply states that if this is our triangle or vector law of addition, so I'll just join these two vectors head to tail. So in this small triangle, I can write OA vector plus AP vector gives me OP vector. And in another triangle, I can write OP vector plus PB vector gives me OB vector. And if we know what OA vector and OB vectors are, if we know these two position vectors, we can easily find we can easily find OP by substituting what AP and PB is. So AP is nothing but, I'll write it down here, N times AP. AP is nothing but OP minus OA vector. Okay, is equal to M times PB. So what is PB? PB can be written as OB vector minus OP vector. So OB vector is OP vector. So I'll simply multiply them and I'll solve this equation. I'll get N times OP vector Remember, n and m are scalars. Okay. So I'll write down n times OP vector minus n times OA vector is equal to m times OB vector minus m times OP vector. Correct? And I have to find what OP vector is. I'll take this, the LHS, and I'll simply get, what will I get? N times OP vector plus m times OP vector. I'll take this, the RHS. So I'll get m times OB vector plus n times OA vector. Okay. And then I'll simplify that equation by simply writing I'll simply write m plus n times OP vector equal to m times OB plus n times OA. Therefore, OP vector is nothing but n times OB vector plus n times OA vector upon m plus n, because m and n are scalars. So this looks a bit complicated, so I'll rename it in a bit more cleaner manner. So let this OA vector be small a vector, let this OB vector be b vectors. So in terms of a and b, if I have to find a position vector OP, so I can simply write down OP vector can be written as m times b vector plus n times a vector upon m n. This is nothing but what is our section formula. Okay. These are fun derivations. You just have to have your basic arithmetic strong and your concepts clear, and it just becomes quite natural that what we have to do. Okay, we just have to divide. If your problem statement is clear enough and your concepts are clear, it's easy to derive all these. Let's move on to what dot product is. Guys, you have to understand that I am covering all this lecture, let's say in an hour or so, but it takes more than an hour to understand, and even more than that to completely master vectors. So let this lecture be just your guide to understand vectors, but if you have to master vectors, you have to practice. It is a skill that you have to develop. You have to practice a lot. That is how you will be a good, you will be a perfectionist. Okay, you will get perfection only if you practice. Let's understand dot product. So what dot product is, it's a scalar product of two vectors. That means if I have a vector A and I am doing a dot product, and how do I represent dot product? By the way, dot product is represented by dot A dot B. If I have two vectors and I am doing the dot product, I should get a scalar. So this is what dot product. And what does this scalar is? How are we getting a scalar by multiplying two vectors? I'll answer all these questions. But to understand what is happening really, let us just take an example of work done. So in a crude sense, in a crude manner, if I have a table and I have to push this table, okay, so it makes completely no sense that I am trying to, that I want to move this table in this direction. I want it to move. Movement is nothing but I want its displacement in the I cap direction. But what if I apply force on the J cap direction? Obviously, it won't move in the I cap direction. Correct. So in this case, my force is not contributing to the displacement that I want. So work done to push this table towards, let's say, I cap is 0. I have done no work. So this is kind of what is the scalar product, that how much is this force and displacement contributing, how much of this force affect this displacement. Okay, so this force does not affect this displacement, so no work is done. So I can say scalar product of these two vectors is 0. So this is how we define work done. So work done is also a scalar product, it's also a dot product. So dot product of these two vectors, A vector dot B vector, in this case is 0 because they are perpendicular. Correct? A and B are perpendicular. Okay. So work done is 0. Okay. So I can write force is perpendicular to displacement. Therefore, no work. So no dot product. I mean, dot product is there, but dot product is 0. So understanding it more, let's go into more details, because details is what makes us, I don't know. So let's understand it in a bit more details. So I have this person again. Let's bring him back. And this person says, okay, I won't push it in the upward direction. He says this table he'll push this table in a bit more angled manner. So this is the displacement that he wants. And this is the direction of force that he's decided to apply. So this is where he applies his force. So angle between these two is, let's say, theta. So all of the force is not affecting the displacement. This force, let's say F force, has two components. Okay. So F force, F vector, can be written as F cos theta I cap. So it has a component in I cap direction. So I'll maybe write it down in another color. So this is what is F cos theta. Sorry. So this is F cos theta in I cap direction. And he has also force in J cap direction. That is how he has applied that force in an angle. F sin theta, J cap direction. Okay. So we can understand that this direction has no effect whatsoever on the displacement which is D, but that displacement D is in I cap direction, right? D I cap. D vector is nothing but d I cap. So what dot product actually does is it takes the product of the aligning vectors. The vectors can be different vectors, they can have different magnitude, they can have different directions, they can have different units. But their product signifies a derived dimension. So in this case, the product of these two, it gives us, what does it give? Gives us force and displacement, gives us work. But what was that work in this case? Work was only done by this I cap direction. Only this thing did work. Work is done. This force was some extra force. This is useless effort, is what I'll say. This is useless force because it did not help me whatsoever to displace that table. What I can say is dot product between F and D, F dot D is nothing but F times D cos theta, F D cos theta, where theta is the angle between them, and F and D are its magnitude. So these are magnitude of F, that mag F, this is mag D, this is the angle between forces. So we have studied how dot product works not only in magnitude angle form but also in component form. So in component form it works in a way that you multiply I cap with I cap, then you forget the direction. Similarly, I multiply j cap with j cap. Since I had no displacement in j cap, the j cap f sine theta was multiplied with this 0. So f sine theta times 0 was 0, so I don't have any components here. But if suppose I had a force, let's say F force is, let's say, 2I cap plus 3J cap. Let's say I have displacement Newton, let's say. I have a displacement in, let's say, I cap plus J cap. This time, what I'll do is dot product with dot product of the similar component. So 2 times 1 is 2, 1 is 2. So F dot D will be 2 1 is 2 and 3 1 is 3. 3 plus 2 becomes 5. 5 joules or Newton meter. Newton meter is joules. Don't take it in a cross product fashion. So I'll explain what that is also. But this is how we get dot product. I hope this explains the basic concepts of dot product. Okay. We can also use a similar concept to find the angle between these two forces. How do we do it? Simply by taking the components of F and components of D and simply dividing it, basically using this formula. Maybe I'll show you guys how to do that later on in this chapter. Let's understand cross product. So the way scalar product of two vectors gives us how much of force, or let's say how much of one vector influences the other vector, cross product of two vectors is the vector product. What is cross product? Cross product is the vector product of two vectors. What is this vector product? So it says that if I have two vectors, A vector, and I am doing its cross product with another B vector, it gives me another vector as an output, C vector. So what is this A vector, B vector, and C vector? Let's understand. So in this diagram, I have these three vectors. Which all vectors do I have? I have X in I cap direction, Y I have in J cap direction, and Z I have in K cap direction. Okay. But then it is clear from this diagram that this x I cap direction is perpendicular to which plane? Why is it plane? Similarly, this j cap direction is perpendicular to the z plane, and this k cap direction is perpendicular to our beloved xy plane. We all love xy, isn't it? So vectors are represented by an arrow, it's true, but for any given vector, any, not a, sorry, any given vector has a plane perpendicular to it. Any vector, take any vector, it has a plane which is perpendicular. Let's say if I draw any random vector, let's say if this is a vector, so there is a plane which is perpendicular to this vector, isn't it? So this cross product essentially tells us that if I have two vectors, these two vectors can form a plane, and the c vector will be a vector which is perpendicular to that plane. So basically what I'm saying you is that area, this is the area, call it area, you can call it a plane. So this plane is essentially a vector. Why is it a vector? Because you can only see that plane if you are at any component to its perpendicular. Let's understand what I'm saying. I'm saying that if I am standing here on the x axis, if some person is standing on the x axis, he cannot see what I've, if another person draws a picture on this xz plane, right? Let's say I draw a simple heart on this xz plane. This person standing on the x-axis cannot see this heart drawn, because if he has to watch this area, if he has to see this area, he has to come out of this plane. He has to become, at least he has to have a component which is perpendicular to this plane. So plane is essentially a vector. You can only see that vector, you can only see that area if you're perpendicular to it. That's why it is defined by a normal vector. That is what is our cross product. So what I'm saying you is that cross product of two vectors is the area vector formed by its parallelogram, and also I'm saying a vector cross b vector gives me a c vector, and c vector has to be perpendicular to this area. Okay, let's derive some things. How do we derive some things? By understanding what it actually is. So let's say this is a vector, let's say this is b vector. So I get a parallelogram. So this is also a vector. Just ignore my accurate drawings, but I think you get the idea. So this is also a vector. This is also, I've just picked and placed this vector to form this parallelogram. I have to find out its area. So how do I find out its area? I find its area by maybe dividing this parallelogram in maybe two triangles, and these two triangles are similar triangles, congruent triangles. So if I find the area of this one triangle, the other is naturally the same, and area of this parallelogram becomes double of this triangle. And say, let's say if this angle is theta between A vector and B vector, I can simply say the height of this triangle is nothing but B sine theta. Area of triangle can be given off as half times base times height. This diagram, it's quite obvious that the base is A and height is B sine theta, because I'm doing the components thing of B. So it is half times base is A, height is sine theta, B sine theta. So area of parallelogram becomes 2 times this thing, so it becomes AB sine theta. Correct. So this is what is the area of this vector, and the direction of this area is perpendicular to the plane. So this gives me a plane, and you watching it is the perpendicular direction of this plane. Okay, so this is how cross product works. So I'll write down in magnitude angle form that magnitude of A cross B is nothing but AB sine theta. See, it's all quite related, because A dot B was AB cos theta, right? A dot B was AB cos theta. Write down here, A dot B was AB cos theta, and A cross B is AB sine theta, because it represents the area. So if I have, let's say, A vector, let's say, is I cap for simplicity, and B vector, let's say, is J cap. So I cap cross J cap, what will that be? So it is simply magnitude of 1 I cap cross 1 J cap, correct? So it represents a plane which is I cap J cap, which is I cap J cap. I cap J cap represents our XY plane. Okay. So its magnitude is obviously 1, but what is the direction of this plane? Well, to look at XY plane, you have to look perpendicularly. You have to look at from the upside direction. So simply I can say I cap cross J cap is 1 K cap, because that is the perpendicular plane to I and J. So I cross J gives us K. And this is where our right hand thumb rule comes into picture. So what right hand thumb rule says is basically, if we have our right hand, let's say if this is I cap direction, this is J cap direction, let's say this is our J cap direction, then place your right hand on this I cap line. So it will be somewhat like this. This is my right hand, and I can curl it. I can rotate this hand. I can curl it to form a fist, but my thumb is pointing in the K cap direction. Okay, this gives us, the thumb gives us the direction of the perpendicular plane. So in this case, I cap cross J cap gives us K cap. Okay, So magnitude gives us 1, but then right hand thumb rule gives us the direction of I cap cross j cap is k cap. Similarly, you can try keeping your hands on j cap and maybe try doing j cap cross k cap. So j cap cross k cap will give you I cap. Okay. If you keep it like this and rotate, you'll get j cap cross k cap is I cap. I don't know how this camera works, but this is how you do it. Okay. J cap cross k. Okay, this is how it works. J cap cross k cap gives you I cap. Correct? This is how it works. So to remember all these things, what you can simply do is either remember this circular diagram I cap, j cap, k cap instead of using right hand. Okay, right hand thumb rule works best. You just have to keep your hand on the first vector, curl it on the second vector, and the thumb will give you the direction of the third vector. You just have to understand what plane it is, and then that plane will have your curl and the thumb will point to the perpendicular direction. I cap cross j cap gives you k cap, j cap cross k cap gives you I cap, and k cap cross I cap gives you j cap. So this is the right hand thumb rule diagram. This is, you can remember this IJK circle and then it's easy to derive it. But the interesting thing is, what is I cap cross I cap? Well, I cap cross I cap is 0 because it has no area. Isn't it? A line has no area. You cannot draw an area, you cannot draw a plane by only using one single line. Similarly, j cap cross j cap is also 0 because it also has no area. Similarly, k cap cross k cap is also 0 because that too has no area. If someone were to ask you what is cross product, then cross product is this if you have magnitude and angle. But if you don't have magnitude angle, then what can you do? Then you guys can simply use this diagram for IJK and I cap cross I cap 0, j cap cross j cap 0, k cap cross. I'll give you a simple example. Let's say if I have a vector A is 2I cap minus j cap and plus k cap. Let's say this is my A vector. I have another vector B. B vector is I cap plus j cap minus k cap. These are my two vectors. So if I have to multiply them, I'll simply use A cross B. If I have to do A cross B, then what will be A cross B for them? I'll have 2I cap minus j cap plus k cap. Then I'll multiply it with I cap plus j cap minus k cap. What will I get? I have to do cross product. So I'll firstly multiply 2I cap with everyone. So I'll get 2I cap cross I cap. Then I'll get 2I cap cross j cap. Then I'll get minus 2I cap cross k cap. This is what I'll get. Okay. Obviously, I'll add them. Then with minus j cap, what will I have? I'll have minus j cap cross I cap, minus j cap cross j cap, then minus j cap cross minus k cap. So minus minus becomes plus, j cap cross k cap, what I'll get. And then I'll multiply k cap with all of these three. So I'll get k cap cross I cap. Then I'll get plus k cap cross I cap with j cap. Then I'll get minus k cap cross k cap. And already we are seeing that what happens to I cap cross I cap, well, it becomes 0. J cap cross j cap also becomes 0 and k cap cross k cap also becomes 0. And we know I, j, k diagram. So I cross j gives us k. This thing becomes k cap. Okay. But then what is j cross I? J cross I will be minus k. So I'll write them down. So this becomes k cap. But then this becomes minus of minus k cap, because j cross I is also minus k cap, correct? Because we are going it in the reverse formula. J this j cross I, it will give us minus k, because we are not going in the preferred direction, correct? So firstly, I'll write down A cross B equal to 2 k cap. What I'll write down first, 2 k cap. Okay, let me write down in that specified color. We'll get 2 k cap minus minus plus k cap. This is done. Then what is I cap cross k cap? I cap cross k cap. We are again going in the reverse direction. So it will give me minus j cap, isn't it? Maybe let me just use another color. I cap cross k cap is in the reverse direction. This is the reverse direction. Also k cap cross I cap. K cap cross I cap is okay, because k cap cross I cap is in the forward direction. It's in the preferred direction. So k cap cross I cap will give me j cap. J cap. This thing is j cap. This thing is minus 2 times minus I j cap. So what I'll write down is, I'll write down plus 2j cap plus j cap. Okay, and similarly for this third thing, what I'll write down is, take another color. This third thing, j cap cross k cap gives you I cap, so this is I cap, but then k cap cross j cap is minus I cap, plus I cap minus I cap. Add them all together to get A cross B is equal to A cross B. A cross B gives, A cross B is nothing but, I'll cut them and I'll write down 3k cap plus 3j cap. So this is quite complicated, this method. So I don't think anyone uses this. So there is a simpler method to do this. The simpler method to solve this is called as determinant method. So let us understand what determinant is. Well, if you have a 2 cross 2 determinant, in 2 cross 2 determinant, let's say I have A, B, C and D. The answer is simply you just have to multiply A with D and subtract it from the multiplication of C with D. So that is nothing but AD minus CB. Okay. So just remember this, but we have to solve a 3 by 3 determinant to solve for solving cross product by 3 by 3, 3 cross 3 determinant. How do we do it? So first of all, we write what A and B are. First of all, let my first vector is 2i cap minus j cap plus k cap. So I'll write down 2i cap minus j cap plus k cap. Then I'll write B vector to be I cap plus j cap minus k cap. So I cap plus j cap plus k cap. So A cross B can be written as, A cross B can be written as, you just have to write down a determinant and just write down these two lines. In the first row, write I cap, j cap, k cap. In the second row, you just have to write 2i, since it is 2i cap, write down 2i cap. Then minus 1 with j cap and plus 1 with k cap. Okay? This is how you do it. And the third row, you have to write down 1, 1, minus 1. Why 1, 1, minus 1? Because B is 1, 1. And to solve this, you just have to write down I cap, then the determinant of, just have to block I caps row and I caps column. So if I block this row and this column, excuse me, so I'll get minus 1, 1, 1, minus 1. So I'll write down minus 1, 1, 1, minus 1. I'll get this. Then you have to write minus j cap. You have to write minus j cap, compulsory. Then the same thing that we did with I cap, you have to do with j cap. You have to hide the j caps row and then j caps column. So I'll hide down, I'll cut this and then I'll cut that. Whatever is left, I'll write down here. So I'll write down 2, 1, 1, minus 1, I'll write down this. Okay. And then again, I'll write plus k cap. It has to be plus minus plus. Okay. And then after plus k cap, you have to hide the k caps row and then k caps column. So if I head down k caps row and then k caps column, let me head down this. Then what do I have? I have 2, minus 1, 1, 1. Okay. And then simply you just have to solve this. And how do we solve this? I've already shown you. This is the 2 cross 2 determinant. Okay. So I'll write A cross B is equal to I cap times minus 1, 1. See, AD minus CB. This is what you have to do. So minus 1, 1 is 1. 1 minus 1 is 0. So 1 minus 1 is 0. Right? I cap times 1 minus 1. Then J cap times 2 minus 1 is minus 2. Minus 1, 1 is 1. So minus 2 minus 1. Then plus K cap. And then it becomes 2 1 is 2. AD minus CB. CB is 1 minus 1 is 1. So 2 minus 1. So it becomes A cross B can be written as A cross B is equal to 1 minus 1 is 0. So 0 I cap is 0. Forget it. Forget I cap. Then minus 3 times minus becomes plus. So I'll write down 3j cap plus 3k cap. And see, we got our answer 3k cap plus 3j cap, 3j cap plus 3k. One and the same thing. So this is how you solve determinant. Sorry, this is how you solve cross product using a 3 cross 3 determinant. This might seem a bit difficult initially, but then the only way to do this is solve many questions. If you solve lots and lots of questions, it just becomes easier. Okay, it just becomes easier to hide this and then find out the 2 by 2 determinant and then solve it. Okay, just try more questions. So this is how we do cross product. What is cross product? Cross product basically means the area. And then we had seen our dot product also. Dot product is nothing but the components. The components, how much the components affect the other vector. Moving on to box product. Box product is nothing but A dot B cross C. Both the things that we had studied in the above sections, dot product and cross product, we just have to combine it. So B cross C gives us a vector, and I am using that vector and I am doing dot product of A with this new vector. Dot product gives us a scalar. So box product is a scalar product. So it gives a scalar quantity. So what scalar quantity is this? Let us understand. So before understanding a scalar quantity, which is, by the way, volume, let us talk more about volume. What is volume? If I give you a volume of a cylinder, what is this volume of a cylinder? Volume of cylinder is pi r square h. If r is the radius of this cylinder and h is the height of the cylinder, then volume is pi r square h. I can split this pi r square h into two parts, I'll write pi r square multiplied by h, correct, into h. Well, this pi r square is nothing but the area of cross section, which is a circle. Area of this circle is pi r square, and pi r square, it's h times the height, gives you the volume, correct. Let's talk about, let's say, a cuboid. So what is the volume of a cuboid? Well, if this is L, if this is the length of the cuboid, if this is the breadth of the cuboid, and this is the height of the cuboid, h, then area of this square on the top, let's say area of that rectangle on that top, area is nothing but length into breadth, L into B, correct? But volume of this cuboid is LB into H, right? So what is happening here is, if you have any shape, you can find its volume by multiplying an area with height, correct? So this is what is happening in box product, because this vector B cross C signifies area, and this area we are multiplying it with a vector. We are not multiplying it, we are using a dot product with a vector to give us a volume. So box product represents volume of a parallelopipe. Now what is this parallelopipe? Let us understand. Let us say that this is the B cross C part. This gives us the base parallelogram part, B cross C. And if A is at an angle, let's say theta, from this B cross C, whose direction is what? We know the direction of B cross C is perpendicular to this plane. So this is the direction of B cross C. B cross C is perpendicular to this plane. So when I'm taking the dot product, so angle will not be this one, but the angle between them will be this angle theta. So A dot B cross C is basically giving us this height. Height is nothing but A cos theta, where theta is the angle between B cross C and A. Since B cross C, see, this angle was with the plane. I'm not talking about the angle with the plane. Talking the angle with the perpendicular to the plane. Correct. So simply height is A cos theta. Then A cos theta into B cross C's magnitude is nothing but A dot B cross C. Correct. Because it represents the dot product. So this is how we get A dot B cross C is nothing but the volume. What is this shape? This shape becomes a parallelopipe. Correct? So it will have volume like this. It's like a cuboid, but cuboid is given some shear stress. Correct? So if you push it like that and keep this fixed, it will kind of, tilt a bit. Correct? So that shape is our parallelopipe. Okay. So I think it's clear what box product is, and since we have already studied about dot product and cross product, then box product is quite natural. Well, one important thing to note in box product is that if you want to prove that, maybe I think so, prove that three vectors A vector, B vector, and C vector are coplanar. So how can we say that three vectors are coplanar? Well, simple, because if their box product is zero, then they are coplanar. No volume. Correct. If it has no volume, then that means they are coplanar. No volume, therefore box product is zero. Okay, by the way, box product is also called as scalar triple product. Okay, so that does with our vectors. Now we just have to study about future scope, that how can we when you guys go in your graduation, I guess at that time you guys might study more about these topics which I am going to cover. That is nothing but tensor. So tensors is nothing but, yeah, in computer programming, background students might recognize arrays. So tensor is an n-dimensional array of data, correct? So this diagram represents a point, a line, a plane, a cube, and a collection of cubes. That is what basically a tensor is. For example, let's say I have a scalar. So scalar has no directions, correct? So it is simply a box which can contain a number, and that number can be any number. Let's say I have 10. So 10 is in that box. So that is just a scalar. So rank 0 tensor is a scalar. Okay. Rank 1 tensor is a vector. It is given in 1D, but it can have various bases. For example, if I divide this one line into 3 bases, I can store any vector in the form of I cap, j cap, k cap. Let that first box be I cap, let that second box be j cap, let that third box be k cap. So this gives us a simple vector. For example, I can store any amount of data. I can store lots and lots of data in this box, and that each box will represent lots of vectors. Rank 2 tensor is a matrix which we are going to study lots in mathematics, and I can give you an example. It might be a bit complicated for you guys, but when we had seen the example of a robot, that time these links and joints, these rotate, and rotation can be expressed in a matrix. That is a rank 2 matrix. And what are these rank 3 tensors, rank 4 tensors? We'll understand what these, well, I may or may not know. I don't know if I'm quite familiar with rank 3 and rank 4 tensors, but this is what tensor is. So tensor is just an array. Okay. And what is vector? Vector is a tensor which has rank 1, only one dimensional tensor you can call it, but in that one dimension it can have multiple other individual directions like this I cap, j cap, k cap. Okay, so it's a lot of confusion about what current actually is. Current is a rank 0 tensor. So is it kind of a scalar? Yes. So basically in current, its actual definition is I is equal to dq by dt. And what is q? Q is charge. What is charge? Well, charges are scalars. And what is time? Time is also a scalar. Correct. So is current a scalar? Yes, current is a scalar, but it has a vector-like property, because in current electricity, we represent something called as an arrow which represents the direction of a current, even though it has no direction. We can see charges are also scalar, time is also scalar. So it has no direction. So what we are representing with these arrows are not the direction of current, but the direction of motion of the ions, let's say positive ions. So if positive ions are moving, so this represents, or holes in semiconductors if you study in further classes. So it behaves like a scalar because two currents can directly add. So if I have 2 ampere in this direction and 2 ampere in this direction, it simply adds and gives us 4 ampere here. Whereas if I were to do this thing in vectors, it would be quite different. Let's say this is our 2D plane, this direction is our I cap direction, this direction is our J cap direction. So if I have one vector right over here with an angle 45 degree, it's going in a plus I cap minus J cap direction. So let's say if this is 2, it's going in plus I cap minus J cap direction. So it has two components, 2 cos 45 and 2 sin 45, right? So I'll write 2 cos 45 degree I cap. Maybe let's say this vector is A magnitude is 2. So 2 cos 45 I cap minus 2 cos 45 minus 2 sin 45 J cap, correct? This is my A vector. Similarly, if I have this B vector, who is also at an 45 degree angle, its magnitude is also 2, then 2 cos B can be written as 2 cos 45 degree I cap plus 2 sin 45 degree J cap. And if I add these two, I can see that the J cap component is getting cut. The resultant is also in I cap, but the magnitude is different. Magnitude is 2 cos 45 plus 2 cos 45, which is 4 cos 45 degrees I cap. It's not 4 like the way we saw in current, where we directly added 2 and 2 to give 4. In vectors, if I am having a vector 2 here and 2 here, let's imagine I have two forces here, then the vertical components cancel each other and only horizontal is left, but it is less than the sum of its magnitude. So I get 4 cos 45, which is 4 into 1 by root 2 I cap. So this is the difference between current, which is a tensor, rank 0 tensor, and vectors. Okay. So where do we use these tensors? So if you guys are interested in artificial intelligence and neural networks, it's all tensors. So these neurons are your rank 1 tensors. Then you have weights and biases in between them, which are like your matrices. And then you have lots and lots of matrices to give you more than a rank 2 to give you rank 3 tensors. So this is how you use rank 3 and rank 4 tensors. It's neural network. I'll give you an example. So I have some questions with you guys. Maybe you guys can try these questions, try to solve them, and try to answer them, or maybe you can discuss it in the comment section. These are the questions. I've got this revision test. Try these questions out. And I have these 2 MCQs. You can write down the answers of these MCQs in the comment section. Well, these are the references that I have used to explain the topics in this lecture. Thank you for attending this lecture. We'll see you in the next one.